record button. We're recording. What do you want from me?
2H.
What's the page?
203 is the last assignment.
203, 202, 3, 2H, solve and check. Am I doing this algebraically?
Either way.
Okay, let's do it algebraically. So 2H, this is not clear. Why? Oh, that's a bit better. Okay. X over 2 plus 3 equals absolute value of 3x minus 3. That was interesting squeaks. X over 2 plus, I'm taking up way too much space, plus 3 equals 3x minus 3. First thing I'm going to do to get rid of the fraction is just multiply everything by 2. So it becomes x plus 6 equals 6x minus 6. Now I'm going to subtract.
You froze.
No, I'm perfectly fine. I'm moving. I can feel my bones and my feet and my hands. Okay, hang on. Let me have an update going on. Let's just stop that. I have my keynote open. Let's close that. Am I still frozen up there?
Yeah.
All right, so I'm going to unmirror and then try again. Don't do this. Just big smile on your face. I'm making noise. Why? Okay. I'm going to finish this quickly here, and then I'm going to go on the board. No, I'm not. I just got to do it anyway. Got to go on the board. Sorry, Kate. We're going kind of old school. I say as I'm still going to record off my laptop. Okay, I'm going to try again because it'll be easier this way. Maybe I'll do this. Maybe I'll mirror first. Oh, I am mirrored.
Yeah.
But now let's see if this bad boy. Stay. Focus. All right. There we go. So I'm doing this stuff here. So it's going to be 12 equals 5x. Divide both sides by 5. 12 over 5 equals x. And if you wanted to put that as a decimal, it's 2.4 equals x, which is a little bit unfortunate if we want to test it, check our work. But anyways, I'm going to do the other one now, and I'm not going to take up so much space.
Oh, because you took it from the other side?
Yeah, because I was getting rid of it on this side. Yeah. Okay. So now I'm going to do it again, except we're introducing a negative sign. X over 2 plus 3 equals negative 3x plus 3. Multiply everything by 2 again, so I can get rid of that fraction because I don't want to deal with that. X plus 6 equals negative 6x plus 6. I am going to add 6x to both sides, so it's 7x plus 6 equals 6. And then I'm going to subtract 6 from both sides, so it's going to be 7x equals 0. X equals 0 over 7, which equals 0. So we have 2 answers. And now we can try them out. Let's try this one out first because it'll be easiest. 0 divided by 2 is 0. 0 plus 3 is 3. 0 times 3 is 0 minus 3. Negative 3, absolute value, positive 3. 3 equals 3. 0 works. Okay. Now this one, 2.4, it's probably going to be easier to do as a fraction. And I won't be able to do it in my head, I don't think, with any confidence. So let's do it this way. So 12 over 5. 12 over 5 over 2 plus 3 equals 3 times 12 over 5 plus 3. How fantastic is this mess? So this becomes 12 over 10 plus 3 equals 36 over 5. Goodness gracious. Plus 3. Well, we can see that the plus 3's are the same, but these two numbers aren't the same. Everything's positive, so we can kind of ignore this. This is 36 over 30. This is 36 over 5. So this doesn't appear to work. So let me just check my math again, because I did it fast. So x plus 6 equals 6x minus 6. Subtract x from both sides, subtract or add 6 to both sides. Yeah, so it doesn't look like this one works. What happened with your, why did you want me to do it?
Oh, I just couldn't do it. I think is it possible to do it without multiplying everything by 2?
Oh yeah, it's
That's
just,
what I was doing and I just couldn't get it.
do you want me to do it that way with the left side, just to see?
Sure, just one of them, yeah.
The textbook said that the 2.4 did work.
Oh, how does it feel to be a liar, textbook? 2.4 over 2 is 1.2. 1.2 plus 3 is 4.2. 3 times 2, oh, that's minus 3. When I was doing my check, I put the plus in. It's minus 3. Let me do the check again. Or I'll do it the other way too, just so you can see. So x over 2 plus 3 equals 3x minus 3. So we're just dropping the absolute value. So I'm going to subtract x over 2 from both sides. So 3 equals 3x minus 3 minus x over 2. If I want to be able to combine these two, I need to change this one. So it'll be 6x over 2. So 3 equals, I'll add 3 to both sides at the same time just to get rid of that negative 3 there. So this will be 6x over 2 minus x over 2. So 6 equals 5x over 2. 2 times 6 is 12 equals 5x. Divide both sides by 5. Yeah, it still works out the same. So 12 over 5 equals x. But yeah, when I was doing my substitution, I screwed this up. So let me just check it again properly. So 12 over 5. So 12 over 5 over 2 plus 3 equals 3 times 12 over 5 minus 3. This is 2 over 1, 1 over 2 is 12 over 10. So 12 over 10 plus, and if I want to be able to add 3 to this, I'm going to put this over 10. So that'll be 30 over 10 equals the absolute value of 36 over 5. And if I want to put this over 5, so I can add it. So it's going to be 15 over 5. Is that right? 5 is 15. This is 10. Yeah, okay. So 12. So that's 42 over 10. 36 minus 15 is 21 over 5. Well, looky. It does work.
Will there be questions like that on the test?
You know what? I was mentioning this in physics, that because this unit's been a bit of a gong show, and I have to take responsibility for part of that. No. The answer to your question is no. What I'm saying in physics is I think I'm going to make it a little bit of an easier test. Doesn't mean don't study, doesn't mean it's going to be, a gimme or anything like that. But I think, any of the kind of questions that really kind of challenge and push, make you think outside the box, we're not going to do that right now, because I think the next unit is going to be a continuation of this. So it's going to be, I don't want to use the word basic because that's one of the words I use when I'm marking. How do I say this? Why am I having trouble? If this is the range of questions on the test normally, where these are the hardest and these are the easiest, I think the hardest will now be kind of somewhere around here. That kind of makes some kind of hieroglyphic sense. That was one question. Next question. Anybody? Nothing? Here's one thing while you consider asking me a question. Something to remember when you are graphing reciprocal. So I mentioned this, I was talking with somebody online on Zoom the other day. Here, let me just. Find something. Give me reciprocal. Transformation. Oh, here we go. That's too easy. Whatever, who cares? So one here says 4 minus x squared. Okay, so what I wanted to mention is notice that let's say you graph this, and now you have to graph the reciprocal. Here's some things, make notes if you need to, or underline, because I'm sure we've covered this, but maybe not as clear as needed to. Where the zeros are, like at -2 and +2, that's where, and some of you are like, yeah, I know this, that's where your asymptotes will be. Okay. So you can write them in right now, like x equals 2, x equals -2. Okay, so that's where we've got our asymptotes down. Now, something else to remember, if you're thinking, okay, well, I know it's going to be these weird kind of curvy things, and I don't know where they're going to go. Wherever y equals 1 and y equals -1, there's a lot going on here. But at y equals 1, and at y equals -1, I'm going to take out the, I think this is too muddled. Those, I'll come back. Those points here, these are where the reciprocal is going to go through. Does that make sense? Like where y equals 1 and -1, that's where the reciprocals are going to go through. So if I put back in my asymptotes, what that means is, stop deleting my points. So what it means is you're going to have one of them is going to go right here. Like one part of the reciprocal function is going to go through here. It's going to go through that point. It's going to go through here. It's going to approach horizontal asymptote, not cross. It's going to approach this vertical asymptote and not touch it. And then it's also going to be here. Same idea. Tricky to draw, but thankfully I've got this. So now I'm going to get rid of a bunch of these things. Maybe just, I'll keep the asymptotes. See, so it goes through where y equals 1 and -1. And then after that, it approaches the asymptotes. Approaches, doesn't cross. Comes close here and here, and it looks like it, but it's not on it. Now somebody was asking, well, how do I know how close this part here is supposed to go down? I don't really care. It's the shape and the ones. That's what I want. The shape and those ones. Does that make sense? Which what? This is for graphing a function and its reciprocal. Same idea. Now those are all quadratics. I won't delete those. I'll leave those in case you need me to highlight them again. But it's the same for just a straight line. Y equals negative x/2 minus 3 or something, whatever. Now, if we do the reciprocal of that, here's an idea, Mr. Thiessen. Talk louder. Just kidding. So this was the line. So this blue line was our original function. 1 and -1 is the same. this -6 where it crosses the x axis, that's where the vertical asymptote is. That's why you can, if just given a function, you can draw its reciprocal. You don't need to know anything else. Put it at the ones, put a mark there. Note where the 0 is. There's your vertical asymptote, and then just draw it in. Does that make sense? Am I making sense? I can't read the room right now. My reading of the room technology is telling me you guys don't need as much explaining as I'm giving. Is that fair? Okay, so I'm still off. All right. Anyways, next question. Anything you want me to go over here? I want this time to be for you. I made a note to tell you that. I actually remembered it. What can I do for you? Yep.
So if you have the graph like before,
Okay, before. There's lots of befores here. What do you want on the screen?
the reciprocal and the function that you graph.
Of this one or the quadratic? Okay.
Yeah, well, it doesn't matter, but when you're trying to figure out which like quote like the coordinates, like which like part of the graph the reciprocals are on. In order to do that, so you were saying you would put it into a T-chart with using the -1 when y equals -1 and 1.
Yeah.
To find out which, could you just show like
So
example of that?
yeah, like do you want me to actually kind of graph one?
Yeah.
Sure. Yes, I can. Okay,
And then like show the math and then like why the reciprocal would be in where it is.
the graph paper. Oh, here it is. Yes. All right. So let's say that we're not told the equation of anything. We're just given the graph of a quadratic function, and then we're told to graph the reciprocal. Yeah.
Yeah.
Okay. So I'm just gonna make one up here. I didn't want to use red yet. Oh well. Just gonna save it for my function. Okay, so I'm also doing this in marker, freehand, no judgment, please. Stressful. 1, 2, 1, 2, 3, 4. Actually, no, I'll just put it here. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. That's terrible. Too pointy at the bottom. Anyways, okay, so we're given crap. We're given this. Okay, you'll be given a better one because I'll just do it with the computer. So what I would do is I'm going to mark my asymptotes. Dotted line, however you want to do that. I've had kids do it where they just draw a straight line and then erase sections from it, whatever. Okay. As long as it's clearly the asymptote. Okay, so I've got my two asymptotes. Now I know that at y equals 1 and y equals -1, those are, there's a word for those points, and it's not in my head right now. But it's going to go through those. So this one's going to look something like this. One's going to look something like, and then this one. Now, the worst part about this is that this one here is moving away from the asymptote. It shouldn't. What'll help is also when I graph like these, each square is worth 1. It'd be so much easier to draw if each square is worth 2. But that's not the way it is for me for right now, because I didn't think that far ahead. But this, like you would lose some credit for that. Not tons, but they need to approach the asymptote. These ones at least are doing a good job faking it. This guy, this arrow is a little crooked, but this is terrible. But otherwise, those points, it's on the red line at the 1 marker, kind of like at the -1 and at the +1. And that's all I need to do. And I could do it inversely as well. If I was given the graph of the reciprocal, I just find those 1 parts, draw it through. Does that make sense? Do you want me to do an example with a straight line or the reverse, or?
Can you explain how that one usually marks for again?
This line
Yeah.
should be approaching the asymptote. It looks like it's bouncing away from it.
Okay.
Like
So
it
getting
should-
Closer, not getting farther.
Exactly. Like it should kind of be the more like, kind of like approaching like this. I didn't give myself enough room.
Okay.
This is nice. It's a little shaky, but Questions about this? Did that do anything for you, Ada? Is that kind of what you're hoping for, or?
Yeah, no, I was just like, I thought that your reciprocals can be in those 3, or they can be kind of the opposite.
Mhm.
But I think if the parabola shape is opening upward, then the reciprocal can only be
This
like kind
orientation.
of in that shape. But like, I would know which like quadrants the reciprocals are in based on the parabola shape opening up or down.
The biggest
Right.
hint, well, I think a bigger hint than that is where the kind of the 1s and the -1s are for the y. That'll tell you where the reciprocal version is.
If it's opening up, is there a way that the reciprocal would be in the upper part instead?
No.
You get what I'm saying?
Yeah. Yeah, like really, you're right. Like you're not wrong.
So I think I was more confused because I saw like it switched, but I didn't like connect it to.
The opening.
Yeah.
Okay. Anybody else? Questions about this or anything else?
Will the text be like a mix of like parabolas and like?
And then you'll have, absolute values of this. And so on. You know how to do absolute value of this? I can do it right over top. It'll make it a bit messy, but the absolute value of this means everything has to stay above this line. So this thing here just gets mirrored. That's 6 down. 1, 2, 3, 4, 5, 6. So it's 1, 2, 3, 4, 5, 6. So in your best smooth curve, oh, that was pretty good. That's way better than this ugly mole. Anything else?
Should we bring a ruler?
If you want, it would probably help keep things. I'll bring my box of rulers.
Like for the reciprocal, would there be like an absolute value for reciprocal? Or?
No, that's getting crazy. Yeah, I just wanted to do it quick while I had it there. How do you find the reciprocal things of other shapes? So that's what Kate's asking me. The only 2 shapes you'll have is this one and the and a straight line, and I can show you that. So if you have a straight line, the question, how do you find the reciprocal? Yeah. The reciprocal things, the reciprocal function. All right. And now I'm going to state that every second box is worth 1. So that'll give me a little bit of, although it won't matter too much, but whatever. So let's say we have a straight line, and I'm just going to draw it here. So putting too much thought into it. Okay, so if I'm going to draw the reciprocal of this bad boy, this is going to be my asymptote, because that's where the 0 is. That's where it crosses the x-axis. So there's my vertical asymptote. And then at the points where y equals 1 and -1, I know that it's going to go through those lines, and I know that it's going to approach the asymptotes. So if you know that's going to go through this, is it vertical, horizontal? No. It's going to be this kind of curved thing. Down here, it's going to be this curved thing. So this is stressful. Whoa, but that's like the best thing I've ever drawn. This one, see, it's curving away. Oh, that's terrible. That's why you have a pencil, because you can fix it. I think my trick is, this is totally good. My problem is I try and get cute and I try and go closer, closer, closer. Well, I'm shaky as it is. It's easier if you just kind of do it kind of extremely goes towards it like this. That just makes it cleaner. Kate, does that answer your question? If you give me a thumbs up, I'm going to look, see if oh, it does. And then the same is also true. If you have, if you just have the reciprocal here, ignore everything else, doesn't have this line, doesn't have the asymptote. Well, it will actually have the asymptote if we're just doing the reciprocal. All you got to do is find the ones, draw a straight line through it. It is that easy, that straightforward. Yes, if the absolute value of this black one, then just bounces. Boom. Yeah. Yepers. Other questions? This isn't meant necessarily to be just answering questions. You guys are free to work like you have. There's those practice questions I'd sent you before. There's a few pages at the end of the chapter. Page 205 to 209 to give you practice. Kate has many more questions, so I'm just going to keep answering questions. You guys can feel free to work. Kate, fire away, sister. And you guys can also ask questions. Yes. Well, that's going to take about 3 days. Page 168, number 9. Number 9. Let's go blue. Okay, so f of x equals x squared minus x. What number was this? I already forgot. 168, number 9. Oh, so all of it. So it might be just not sure what the question is asking. So when it says f of x equals x squared minus x, for part A, it says f of 2x. What that means is you put 2x in for every x. So that equals 2x squared minus 2x, which equals 4x squared minus 2x. Jumping to D, which makes it harder, but this is f of x plus 1. So all you're doing is you're putting x plus 1 in for every x. So now it's x plus 1 squared minus x plus 1, which is x squared plus 2x plus 1 minus x minus 1, x squared plus x. That's what you're left with. I did that super quick, but this isn't just x squared and then 1 squared. This thing here is x plus 1 times x plus 1, which doesn't equal this. It's a separate animal. Are you okay with that, Kate? Oh, wait, I don't, you might be giving me a thumbs up. Hang on. Did I miss a thumbs up? Yep, okay, 8D. All right. Anybody here have questions about this? You guys are off on your own already. Okay, just shout or yell or kick over a water bottle if you want my attention. Okay, what did she say? She said, oops, that's the wrong button altogether. 8D. Okay, so 8 D f of x equals 1 minus 3x squared. And then f of negative 1 over 3. So equals 1 minus 3 times negative 1 over 3 squared. So you're just plugging it in for whatever the x is. So 1 minus 3, negative times negative is positive. 1 over 3 times 1 over 3 is 1 over 9. 1 minus 3 times 1 is 3 over 9. So that's 1/3. 3 over 9, 1/3. Change this to a denominator of 3. So that's 3 over 3 minus 1 over 3 equals 2 over 3. You're just putting this in for whatever x is. Can you dig it? Cool beans. Yep, Brianna?
Can you do 2E from yesterday's homework on page 203?
2E 203. I can and will. I can find it. Two E?
Mm-hmm.
All right. I might run out of space. So. Two E, page 203. 2x minus 4/3, so 2x minus 4 over 3 equals 2/3. All right, so the first way we're gonna do it, just drop in the absolute value symbol. So it's 2x minus 4 over 3 equals 2 over 3. First thing I want to do is multiply everything by 3, just to get rid of those fractions. You don't have to do it that way. It's just the way I do it. So 3 times 2x is 6x. Cancels that fraction and cancels this one. See how much nicer this is? Going to add 4 to both sides. 6x equals 6. X equals 1. Going to do it again, but with a negative sign. So 2x minus 4/3. Doesn't matter which side you put the negative on. I always like to put it on the one that's simpler. If I was going to put it on this side, I change both signs. So anyways, multiply everything by 3. So that's 6x minus 4 equals negative 2. Now I'm going to add 4 to both sides. 6x equals 2. X equals 2 over 6, which equals 1 over 3. But now we got to test them. You want to do that too? Okay. So now to check them, I'll just keep my answers in view. So this is going into 2x minus 4. So this is 2 times 1 minus 4/3 equals 2/3. So this becomes 2 minus 4/3 equals 2/3. If I want to change the denominator here so I can add them, I'm going to put this over 3. So it's going to be 6 over 3 because that still equals 2. 6 over 3 minus 4 over 3 does in fact equal 2 over 3. I'm showing every step here. Checks out. And then for the other side, it's 1/3. So 2 times 1 over 3 minus 4 over 3 equals 2/3. This is 2/3 minus 4/3 equals 2/3. 2 minus 4 is negative 2. Negative 2 over 3, but it's absolute value. So it will be 2/3. That one works too. I can graph one of these too if you want to see me do that. Yeah? Does it matter which one?
No.
Okay. Are you okay with this?
Yeah.
Anybody need more time writing this down before I switch over? If anybody was? Not seeing anything from Kate. All right. So let's graph one of these bad boys. Bless you. Let's do F. So this is going to be 2F, page 203. Okay, so I'm doing x plus 1 equals x minus 1. You're not laughing at me, are you? Like, do I have a booger hanging out of my nose or anything? All right. Getting self-conscious over here. Bad enough I got big ears and a bald spot. All right. So first thing I'm going to graph is the x plus 1. So x plus 1 is I'm going to say that each 2 squares is 1, just to give me, again, some breathing room. Anyways, x plus 1 means that's the y-intercept. The slope is 1. So the rise of 1, run of 1. So this absolute value would go that doesn't feel right. Hang on. Now it's absolute value, so it kind of would normally go down this way to here. So that's 1, 2, 3, 1, 2, 3. Okay, so normally this line would go down to here. I'm just doing the mirror image. It goes 3 down, so I'm just going 3 up from there. So this is the absolute value right here. And then x minus 1 y-intercept here. Oh, this is going to have no solution. I can see. It's got the exact same slope, which means it's going to be parallel to this. It's going to go this way. Never going to intercept. There's no solutions for that one. Yep.
How do you know that it goes down 3?
Just okay. So if I would have graphed, the reason I didn't do it is because it's marker and it's too prominent. I don't want you staring at that thing and it's the right answer. But if I were to continue along this path, like I'll use a pen so it's just lighter. So following along this path here.
But you can use like any point. You don't have to.
Totally.
Okay.
Oh,
I thought you meant that
thank
it
you.
stops there. and I'm
Nope,
like, how
that's
do
just
you-
as far as I went.
Okay.
Like I could have chosen this spot right here. That's like 1.5 blocks, or sorry, 3 blocks, or 1.5 on our chart. But 1, 2, 3, it's exact mirror.
Oh, okay.
Yeah, thank you, Sadie, for seeing through that. But to continue on with this this x minus 1, there's not going to be any solutions because they're parallel lines. Did I say you can get out of your seat, Nathan?
Do you have the graph paper?
Take as many as you want. There'd be no solutions to that one. I didn't pick one with no solutions on purpose. But if wherever they would have connected, wherever they would have intersected, if they did, that's your solution for the x value of that. So if for some reason, let's say this red one crossed like right here, went that way. So this point right here is x is 1, 2, 3, 4, 3.5. So this is negative 3.5, that would be the solution, if that's where it would have went through. Page 191, 1B and D will be next. But before I do that, are you good with that, Brianna? Anybody else questions about this that's up here? Just gives me the thumbs up. It's under control. All right. One what? 1B and D. 191, 1B and D. Don't use pen. Green light up there? Oh, that's actually not bad, eh? Can you guys see that okay? No, okay, I'll use markers. 191, 1B. What is this even asking? Given the following functions, identify the values of x for which that will have vertical asymptotes. Okay, so 1B. It says f of x equals 2x minus 6. So basically, we got to find our zeros. It wants to know what are the asymptotes. If it were, in other words, if it was 1 over 2x minus 6, what are the non-permissible values? The easiest way to do this is to say 2x minus 6 equals 0. Solve for x. Because then whatever x is what would make it 0. Add 6 to both sides, 2x equals 6. Divide both sides by 2, x equals 3. There's your vertical asymptote. X equals 3, because 2 times 3 is 6, 6 minus 6 is 0. It would make the denominator 0. Got a thumbs up? Anybody in class here have a question? Good. So D now. Yep. 2x squared minus 5x minus 3. So that one you got to factor. Oh, that's 2. Sorry. I'm at 1D. Oh, that's the exact same question. 2x squared minus 5x minus 3. You got to factor. I wish Ada was here for this. I was talking to her about this the other day. So 2x and x. It's going to be 3 minus plus 1. So now you're going to have two values that are going to give you two vertical asymptotes. When you graph this, there are 2 points where it crosses the x-axis. Those are your zeros. And it's the same thing over here. You make each of these 0. So you can probably, you'll get to the point where you can just look at it. Like here, you can tell, well, x is 3. Because 3 minus 3 is 0. This one might be harder to see right off the hop. It'll get easier. I'll just do it out just in case. 2x plus 1 equals 0. Subtract 1 from both sides. 2x equals negative 1. Divide both sides by 2. X equals negative a half.
And you got the 1 and 3 from factoring the.
Yeah.
But so that's by multiplying the 2 and 3, but that would equal 6, wouldn't it? So then you're adding to equal 5 and multiplying to equal 6. So why would 1 and 3 work?
Okay, good question. And that's kind of why I was saying I wish Ada was here, because we were talking about this the other day. I don't like the kind of the longer way of doing it. There's no problem with that, and you will need to do that more often than not at this stage of the game. But it wasn't necessary, and so it's just quicker for me to just kind of fill in the blanks. I'll tell you the way I did it and why. If it's a 2, there's going to be 2x and x, or it could be x and 2x, but it's just going to be one of those situations. And a 3, the 3 is either going to be here or it's going to be here. Well, I see that 2 times this equals 6. What we're going to need to find is a difference of negative 5. Like when I multiply this through, 2x times x is 2x squared. 2x times negative 3 is negative 6x. 1 times x is plus x. And then 1 times negative 3 is negative 3. So I've got my 2x squared, got my negative 3, and then these two combine to give me negative 5. Okay, so I just did it that way because there's very small possible combinations. If these two numbers here aren't prime numbers, good timing. If these two numbers here aren't prime numbers, then I'll do it the longer way. Because if this is a 4, then it could be 4 and 1, could be 1 and 4, could be 2 and 2, and so on and so forth. Does that make sense? I was just saying, remember how we were talking the other day about, like you can do the kind of the long way of factoring, and sometimes it's the shorter version. I was just doing the shorter version. It's not making sense though, because you weren't here, but watch the video. Who wanted this? This was Kate. Kate, are you good with this, sister? Yes. Anybody else questions about this one? Any other questions? At here or at home?
When you're recording and we're watching the video, often during the notes, the people on the side are covering up the notes, like the screen to the side, so like
So be aware of that.
So
Okay,
when you're recording, you could like press the
minimize.
whole thing.
Okay, is it still like recently it's still happening?
Yeah.
Crap.
I
Like
can't see
yesterday.
some of the notes.
Yeah,
I wonder if it's different from me from what I see.
Like, watch the video you put on YouTube, it like covers the end sentences, so you just kind of guess.
You
kind
just
of
gotta guess what it is.
Well, the good news is if you're live at the lesson, you can tell me. But yeah, sorry, that's weird because I thought I was pretty aware of it. So I wonder if it's a little bit different from me. Like, do you guys see? I'll move, like sometimes there's 4 or 5 people and I'll move it and all of a sudden the box goes across the top.
No.
Oh, see, for me it goes across the top, but you guys, I guess it stays there, and that's why it's blocking, and I don't see that.
Well, when you like present the slideshow, can you do that on a Zoom? Like, you can click present.
Yeah.
Would it then make the things go away for us, or would it still cover it?
No.
I guess it's because
It's different for like physics because I use Keynote, and then pre-cal is slides, and they might have their own animal. Because I know when I'm using Keynote in physics, it's a pain. I can't have access to my Zoom stuff. So that's interesting. Okay, see, I was thinking like because I'm watching, I'm seeing what you guys are seeing, but clearly I'm not. Okay, bummer. Sorry about that. Any questions about those? Like anything in the notes that you think? I think the important in math more so than physics, it's important to how to do stuff, Anyways, next questions. Kate or anybody else? Yep. Oh, Brianna and then Nasidi. Oh, and then Kate.
Go ahead.
Kate's like, okay, I got 6 for you. Okay, Brianna.
Can you do one from the review? Is that okay? Like,
Yeah, which one?
can you just do number 2, A and B? I know what to do. I'm just confused about how they.
Page 205.
Yes.
Okay, so Susan was paid a bonus of $2 and a fee of 30 cents per pound to pick strawberries. So her pay equals 30 cents, so 0. Holy complaining. Just kidding. I'm just kidding. Thank you for telling me. This is number 2, page 205. So the pay is 30 cents per pound. I don't want to use a P. I don't want to use LB. So X. 30 cents per pound where X equals pounds, plus a bonus of $2. So plus 2 where X equals pounds. So that's the function. That's the rule. That's the equation. And then graph it. Do you need me to graph it, or was that the hardest part of it?
Well, I got like the 2 on the graph, but then.
Yeah, the slope is wonky.
Yeah.
Again, you'll get cleaner numbers from me. But that slope it's a rise of 0.3 over a run of 1, or a rise of 3 over a run of 10. So if the intercept is at 2, so I say 3, so it's like 1, 2, 3 over like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'll be like a slope, something like this. Does that make sense? So 0.3, that 0.3 is 3 over 10. So rise over run. Yeah, and this isn't like, that's kind of a stupid question because were you given many, if any questions like this during the unit?
No.
This particular chapter, I think is terrible. I really like these new textbooks, but this one is brutal. This one, it's like a rush to print or something. What was your question, Sadie? Are you okay with that?
Yeah, I'm good.
You're good?
Yeah.
Okay, Kate. I'm gonna have to write these down. 197, 1A, 2B, 3B, and E. Wanna be Kate. All right. Have you heard that song yet, Kate? Probably not. 197. Tomorrow's also study day, 9 a.m. I'll be online if you have questions. It's a full day for me. I got to supervise a bunch of other classes in the building. So if you have questions, ideally you'll be there in that class because it'll be tricky for me to record anything and post it. I still can, but it won't be till like end of the day. So just know that.
So if you have a question at like 1 p.m., email me.
Yep, totally. I just might, and if it's an emailable response, yep, for sure. But if I'm gonna record it, it won't happen till after 2:30 at the earliest.
Are you gonna post like what you usually do? Like,
I'll do that before the end of the day today, yeah. Okay, 197. 1A. What new equation should replace y equals absolute value of x to change the graph as follows? Okay, so number one, y equals absolute value of x. Stretch the graph horizontally by a factor of 3. See, the horizontal stretch of 3 means a vertical kind of shrinkage, which means y equals 1/3 x. Horizontal stretch is a vertical compression. A vertical stretch is a horizontal compression. 2b. Oh yeah, we were talking about this one the day I assigned it as it still on the board. And I was thinking about it after. It's a terrible question because I thought, oh, whatever, I'll just answer the question. I hate this one, I'll tell you why. Because it looks like an absolute value. If this is like, oh, it bounced off of there to there, we don't have an absolute value that's going sideways like that. This is an inverse absolute value, which we haven't even done yet. This is x equals the absolute value of y. That's what this would be. But to answer the questions here as they're listed, and I didn't see that at first because I just assumed they wouldn't give you something like that. To answer the questions here, the domain, what are all the possible x values? Well, arrow's going on forever to the right, arrow's going on forever to the right, but to the left, it stops at the y-axis. So x is greater than or equal to 0. X is greater than or equal to 0 for the domain. For the range, y values, it's always going up and always going down. Y is an element of reals, negative infinity to positive infinity. The x-intercept is at the domain, so it's at 0. Same with the y-intercept, both are at 0. That's where it crosses. Well, and even the y-intercept, it's tricky because it's touching, but it doesn't actually go across, but I'd still say 0. You won't get a question like this. You very much could expect one like this, totally. And this one, this is a gong show, frustrating. You okay with that, Kate? Anybody else questions about that one? Should I keep going? 3b. Graph each absolute relation using y equals. Okay, so for B, that was pretty straightforward in that all you're doing is you're doing an absolute value function, just y equals absolute value of x. You know, I'll do it really quickly like this, and if you need it better, I'll do it. But this there, that's y equals absolute value of x. It wants us to do, which one is this, 3b? It has it written as y equals -1 plus absolute value of x. You could also write it this way if it makes you feel better. Absolute value of x -1 just means the whole thing goes down 1. That's it. So this is at the origin, goes down 1.
How is an absolute value?
It's just the x that's absolute value.
Okay.
So whatever number you put in for x, negative infinity becomes positive infinity -1.
So you would graph the absolute value or whatever is inside the absolute value signs, and then whatever's on the outside you would do after.
Yes, I think your wording was a little bit wrong, but yes to what you're meaning, I think. So like you put that number in, you apply the absolute value to it, and then you subtract the 1, and then you graph it. Then you put it on paper. Because it sounds like you said you
Right,
graph
no,
with,
no, no,
yeah, okay, so we're good.
And will there be a question like that?
Totally within the realm of possibility. Yep. I also totally need to make the test. Kate said, oh, sorry, I meant D. Oh, sure. Once I'm done the question. Okay, x plus 2. All right. So for this one, which is funner, anyway, 3, well, that was 2b? 3. Why did I label it 2b? Oh, because I was just looking at the book. Okay, 3d, y equals absolute value of x plus 2. Think of your transformations. If it's like y equals, if it was y equals x plus 2 squared, you would move it 2 to the left. And that's all you're doing here. You're moving this thing here, except you're moving it 1, 2 to the left. And you're doing it in green. So it's the exact same shape. Oh, this marker's dying. But it's moved over 2 to the left. And if you're not sure, you can always use the table of values. So when x is -3, y is -1. When x is -2, y is 0. See, that's why it's there. -1, 1, 0, 2, and so on. So notice that the y-intercept is going to be at 2. I feel like I'm answering this a little bit too quickly.
Wouldn't it be 1, not -1, because it's absolute value?
Oh, yeah. You are correct. These two kind of tell us tons of what we need to know. Your intercepts place things for you. Yeah, sorry, I wasn't thinking
But
that.
it's just y equals absolute value of x is going to just go up 1 and side 1, up and side 1.
Yeah, it's mirrored from the origin. Yeah. Kate, is that okay? If it's not, I can do more. So, like it's like that regarding transformations. If you're thinking of it, how transformations will move things, yes. Granted, it'll have a somewhat similar shape. Her question was, so she was saying basically, so it's like this, and it is as far as transformations go, because our default is like y equals x minus h squared plus k. Minus is the default. So if it's positive, it means it's going to go left. Anybody else? There's one more Kate question. Oh, it's really close to ending class too. Last question, 3E. Okay, so this one, 1/4. Again, I'll just do the quick version. If you want me to do longer one, I can. No. Sorry, I keep forgetting to check my screen. So y equals absolute value of x is just, these should touch. That was sloppy of me. This one, every y value is 1/4 of what this one is. So it's going to be horizontally stretched, vertically compressed. So whatever, like in a straight line value, if this was, let's say this here was 4, well, this is going to be 1. Yep.
I have a separate question.
Hang on just 1 second. Is that okay, Kate? I know I gave it kind of a quick, yeah, we're good. Brianna.
Can you do 1D from the homework assignment on 203?
What time is this class over?
225.
Oh, we got time. I thought it was over. Sorry, what page and question again?
1D.
This is why I can't remember what time class ends, because I can never remember anything.
Page 203.
Okay, and what about it? You want me just like to graph it?
Yeah.
Okay. So the absolute value of 3x plus 6. Go graph paper. Anybody needs graph paper? There's lots here. It's getting thinner, but I have stacks in my office I can get. All right, let's graph this bad boy and let's keep it on camera. Now, I think I've said before, you are more than welcome to use a table of values. You don't have to. It takes time. If you understand it and you can go without it, then go without it. This is, sorry, Brianna, D.
Yeah.
So y equals absolute value 3x plus 6. So that means that the y-intercept is 6. So it's 1, 2, 3, 4, 5, 6. It's going to go through this point, and the slope is 3, which is 3 over 1. So it's 1, 2, 3, and 1. 1, 2, 3, and 1. And it's going to continue that pattern. It's absolute value. So I'm going to try and draw it a little fainter as I pass below the x-axis, just because it's this crazy marker. Whatever. So it's a hair thinner, but that's where it bounces off of. So I can just pick a point somewhere along here and match it and then connect. So there's a point there that I could use. There's a point there, there's a point here. I'll take this one. So this is 1, 2, 3, 4, 5. So it's right above there, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I can use any point along this line. I could use this one. It's 3 down, so I go 3 up. 1, 2, 3, and you'll see like these 2 points are in line with each other. Try to not go over the line like I did there. So it's that, not this. This should have been lighter or dotted. You can erase this because you'll have a pencil, because that's what you write tests with. Does that make sense?
Yeah, it was just the same thing about like, what's it?
Where over here?
Yeah.
Yeah. And like I said, you can use a table of values if you want. It'll work totally fine. I find this quicker and easier and does all the work for you. Anybody else? Quick questions before you go?
You could do 3C from that assignment.
That same assignment?
Yeah.
4 equals the absolute value of 3 minus x?
Yeah.
Yes, I can do that. Four equals absolute value of 3 minus x. All right, so the first thing we'll do is just drop the absolute value symbols. 4 equals 3 minus x. Subtract 3 from both sides. So I've got 1 equals negative x, which means negative 1 equals x. And then I could do it the other way, where I say negative 4 equals 3 minus x. I subtract 3 from both sides. Negative 7 equals negative x, which means 7 equals x. And so now when I check, 4 equals the absolute value of 3 minus negative 1. 4 equals 3 plus 1, which is 4. That works. On this side, 4 equals 3 minus 7. 3 minus 7, yeah. 4 equals absolute value of negative 4, which equals positive 4. Negative 7? Oh, I was like, that's not the right answer. Okay. Does that make sense? Yep.
I'm just confused about, this is my dumb question, but where it says negative 7 equals negative x, how can you just make them both positive?
You kind of divide both sides by negative 1 or multiply both sides by negative 1. Not a dumb question.
I forgot that there's a 1.
Yeah.
Okay, wait, why is it?
Because the answer is 7. So what are you asking? Did I understand you correctly?
No, I'm just confused. No, we're working.
Because I was like, if you multiply, okay, never mind.
Yeah. Whatever you do to one side, do to the other.
Yeah, I was like, if you
Oh,
divide it
I
by
get it.
1, then there's going to be an x, but then I realized that.
Yeah, it cancels out.
Why is it there?
You're free to go. Sorry for keeping you. Kayla, can I talk to you 1 second before you go, please?
Yeah, we have to do that.
199. Okay, Kate, I'm going to keep going with you, sister. I'm just going to mute myself for a second and pause recording. I'll be with you in 2 seconds, though. Okay, Kate, 199, 4C, and 5E. Let me just write this down. I'm going to use a pen too because nobody else has to see this page. 199, 4C, 5E. 4C, 5E. Real quick, yeah. Sorry, Kate, give me 1 sec, sister.
If this is if there's a +6 here, meaning it moves 6 upwards, shouldn't this one start at +6? Or am I crazy? And I think, I don't know. I'm getting
No, see, that's with the y-intercept is at 6.
it's saying the y-intercept is at 6?
Yeah, like your thing, this is a straight line. If it's a parabola, then the whole thing moves up. And then, but then it's also got to be in the right kind of, am I right on this one second?
Yeah.
Then it'd be like y equals like x minus whatever, so make up a number, squared, plus 6. Then it's a completely separate over there kind of animal. But here it's a straight line. So it's the y-intercept. Here, it's not the y-intercept.
Got it. I think
Okay,
I'm
okay.
confusing the two.
No, it makes sense that you're thinking that way. It makes sense that you're thinking that way.
Sorry.
Try not to wreck the world, please.
Yeah, my bad. All right, thank you.
Yeah, no worries. All right, Kate, sorry about that. 199, 4C. I just gotta find it. Four x minus 1, sketch that and the absolute value. Okay, 4C, so this is y equals 4x minus 1. All right, that and the absolute value. Okay, so for 4x minus 1. All right, so -1 is going to be the y-intercept, and it's a slope of 4. 1, 2, 3, 4, and 1. Make sure this is good. Keeping my slope. 1, 2, 3, 4. So it's over there. You forgot your noisemaker. Okay, so this is y equals 4x minus 1. And then the absolute value of that bounces here. It's not a nice, neat kind of place for it to bounce, but that's just what it does. I'm going to go here. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that point is going to go through there and keep going. Does that make sense? This thing here is the original, and then up top is the absolute value. Cool, cool, cool. And then the other question you wanted was 5E. So it's just the absolute value. Okay. Oh, goodness gracious, heavens to Murgatroyd. You won't get something this complicated on the test. Do you want me to still do it, or is that enough for you? This one is depending on technology. You still want me to do it? Yes, that's a thumbs up to still doing it. Okay. Okay, this is 5E. Write it down so I stop checking all the time. 5E. All right, so the it's going to be 3 and 4. 1, 2, 3, 1, 2, 3, 4. That's the vertex. It is a negative, so it's going to open down. I'm going to find out what the y-intercept is, just so I have kind of an idea of the shape of this thing. So when x is 0, 3 squared is 9. 9 times 2 is 18, and 4 is 22. Okay, so let's do this without absolute value. Negative 18, so negative 14. So it goes way down. 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. So it goes way down. So anyways, you're gonna have something like this. And then because it's absolute value, it bounces at these points. Except it wouldn't cross here. It should be higher up because it has to be the mirror of the bottom. Does that make sense? I keep saying mirror, and it should be like I went out like this. It should have been much more kind of harsh. Again, pen, kind of like that. This looks like some poor animation. Somebody's reaching for their life or something. Does that help? Is that okay? Any other questions? The thumbs up is staying there. Does that mean there's more questions or no? Oh, we're done. Okay, we're celebrating. All right, sister. Hope you're doing okay there, being at home and such.